Hello बच्चों, in this video we will study the variation in the acceleration due to gravity, due to height, due to depth, due to shape of earth and due to rotation of the earth. First of all, let us see what is acceleration due to gravity. This is the acceleration acquired by a free falling object due to gravitational pull of a massive object, for example earth. So the first variation in G due to height. Let us say that this is our earth, this is the center of the earth, this is radius, this is point A and this is point B. It is at a height h. This is center of the earth. Now if we know the relation, that is Z is equal to Gm upon R square. This is the relation between small g and capital G, and let us say that this is the value of acceleration due to gravity at this point A. Then the body is taken to a height h. So at this point the acceleration due to gravity becomes h and the distance becomes, you can say, R plus h whole square. Just we have to compare, that is Gh upon G, it is equal to Gm upon R plus h whole square divided by ये R square ऊपर चला जाएगा upon Gm. These terms cancel out and this is R square, this is R plus h whole square. We can take R square as the common. R square it is equal to 1 plus h by R raised to power 2. This R gets cancelled and you are left with the term that is 1 plus h by R raised to power minus 2. This is left hand side. This is Gh upon G. It is equal to 1 upon h upon 1 plus h upon R raised to power minus 2. This whole denominator is taken, the minus power becomes minus. So using and expanding it using binomial theorem, what you get, this is equal to 1 minus 2h upon R, and it is assumed that h is very smaller than R, so higher powers are neglected. So in this case you can see that is Gh, it is equal to G into 1 minus 2h upon R. So clearly from this equation you see that as we take the object from surface of the earth in the upward direction, the Gh goes on decreasing. So Gh is equal to, Gh is less than, it is G. So G goes on decreasing. This is 1 minus 2h upon R. Now let's come to the second case, due to depth. Due to depth. Before coming to this article, we will make it clear that our earth is a solid sphere of uniform density. Spherical cells of smaller size are placed one upon the other, then second, third, fourth and so on. That is the construction of the spherical cells. दिस स्फेरिक एक के ऊपर सेंटर में बिल्कुल छोटा स्फेरिकल सेल है, उसके ऊपर दूसरा, तीसरा, चौथा एंड सो ऑन. Then we have the uniform density for all practical purposes. So the earth like this, it is of uniform density rho, mass of the earth, and this is radius of the earth. This is of course center. When the object as point A, then you can say GD. GD you can write down very in simple terms. GD is equal to, आप इसको लिखिए, let us say the acceleration due to gravity at A is Z. It is equal to Gm upon R square. This is radius of the earth. Now mass is equal to volume into density G. This is 4 by 3 pi R cube. This is volume and this is of course density and this is R square. This term goes off. the acceleration due to gravity in terms of the mass and density, that is equal to 4 by 3. This is z pi r rho. Let us call this as equation number first. Similarly, let the body be taken to a depth. ये देखिएगा depth है. Be careful at this point. This is depth d. Now the distance object is at this point. This distance is r minus d. Now when the object is at point B, the effective portion of the earth is of radius r minus d. The upper portion beyond B is nothing to do with the body. So the acceleration due to gravity at point D, it is equal to, I will directly write down, that is 4 by 3 z pi, this is r minus d, and this is rho. This is equation number 2. This is the value of acceleration due to gravity. You can simply find out in this way. Then let us compare it. That is gd upon g. It is equal to 4 by 3 g pi r minus d rho upon 4 by 3 g pi, this is r rho. These terms get cancelled and we are left with r minus d upon r. So r can be taken outside in the numerator, r into 1 minus d upon r. And of course this is r. So this is zd upon g. This r gets cancelled. So you can say it is very clear that gd is equal to g into 1 minus d upon r. That is, acceleration due to gravity goes on decreasing as we move, as the object is taken inside the earth. Now what happens if d becomes equal to r? Let the body be taken from this A to the central point O. Then this d will become equal to r, and therefore the acceleration due to gravity in that case will be equal to 0. So g will be equal to 0 and the object will be in a state of massless, weightlessness. यहाँ पर उसका कोई भी weight नहीं होगा at the center of the earth. Now let us come to the third important point. Variation in acceleration due to gravity due to shape of earth. Shape of earth. That is, we know that our earth is just like this way. It is in this form. That is, equatorial diameter is more than the polar diameter. So this is A, this is O, this is B. You can say this is R1, this is R2. So at pole, this is pole, north pole, this is south pole. So when acceleration due to gravity at pole A, you can say that is equal to, you can write down Gm upon R1 square. Now let the same object be taken to point B. So acceleration due to gravity at point B, that will be equal to Gm upon R2 square. Clearly, if you compare, that is R2 is greater than R1, and therefore you can say Ga, the acceleration due to gravity, that Ga will be more than Gb. It means that if you weigh some object on pole and it is taken to equator, it will lose weight. It means that acceleration due to gravity is less at the equator than it is at the poles. Then we come to the last point, that is variation in G. Variation in G due to rotation of Earth. Due to rotation. Rotation of Earth. Let us see this diagram. This is Earth, and let us say that Earth is revolving. It is moving along this axis in this direction, and this is central point. Let the object be placed at P. This is point P, and this is the angle lambda. The lambda is known as the latitude angle. This is equatorial line. What is latitude? It is the angle made by the line joining the center of Earth and particle between the OP and equatorial line. Lambda is the latitude angle. It is defined as the angle which is made by the line joining the center of the sun to the planet and the equatorial line. Now, as the Earth is rotating, there might be acting some centrifugal force. It is a accelerated frame of reference. The Earth is rotating like this way. So, the centrifugal force will act in this direction. This is m omega square r. Of course, this particle will also describe a circle of radius small r along this axis. Now, this centrifugal force, which is pseudo force, imaginary force, and which comes into play in case of accelerated frame of references, that can be resolved in two components, one along this and one along this. This is m r omega square sin lambda, and this is m r omega square cos lambda. And of course, the weight of the object is acting in this direction mg, and this angle is also, this is p, this is c, and this angle is lambda. This angle is also lambda. So the m r omega square sin lambda is balanced by the weight of the particle, and this force is responsible for this variation. Now you can see the two forces are acting on the particle. One is Pu, that is mg, and the other is mr omega square lambda. So the effective weight you can write down, that is mg lambda. It is equal to mg minus mr omega square cos lambda. Now in this triangle PCO, you can write down, we have to find out the value of, this is PC. PC की R की वैल्यू फाइंड आउट कीजिए. दिस इज एंगल के सामने परपेंडिकुलर है. दिस इज परपेंडिकुलर, दिस इज बेस, दिस इज हाइपोटेन्यूज. हाइपोटेन्यूज इज द रेडियस. So this is R upon capital R is equal to cos lambda. Therefore you can write down R is equal to R cos lambda, where lambda is the latitude angle. So you can write down that is mg lambda. It is equal to mg minus m. R की वैल्यू पुट करिएगा, R cos lambda. This is omega square. This is cos lambda. I am making it very simple. That is mg minus mr omega square. You can write down this is cos square lambda. So m goes off. It is obvious that acceleration due to gravity, due to rotation of the earth is less than g. That is r omega square cos square lambda. This is the change in variation in acceleration due to gravity due to rotation of the earth. Now you simply can write down if lambda is 0. Lambda 0 कब होगा? When the particle is at equator. Cos 0 will be equal to 1, and therefore g on equator will be equal to g minus r omega square. Similarly, if you take the object particle from this position to the pole, this angle will be 90 degree and cos 90 0. So acceleration due to gravity will be equal to acceleration due to gravity lambda. दोनों बराबर हो जाएंगे, कोई चीज इसके अंदर नहीं होगा. Now I am going to explain something important. What happens if Earth suddenly stops spinning? Spinning, Earth की रुक जाए तो क्या होगा? What will happen? The very simple thing, if Earth stops spinning, then what we will have? 1 year day and 1 year complete night. इसके अलावा बहुत ज़्यादा टेम्परेचर के अंदर वेरिएशंस होंगी, एंड मैसिव अर्थक्वेक्स आएंगे, and there will be catastrophic winds. पूरा विध्वंस हो जाएगा and nothing will save. That is the everything placed on the surface of the earth will fly away with very high speed into the space. बड़ी आंधी आएगी, तूफान आएंगे, टेम्परेचर वेरी होगा from minus to 1000 degrees Celsius, and that will be the sea. Now what happens if the earth starts revolving around the sun? For revolution, you know that centripetal force is necessary. If revolution stops, there will be no centripetal force and the earth will be stationary in the orbit, and consequently the earth will be pulled by the sun toward itself. It will come nearer to the sun, and what will happen? Its temperature will rise and it will vaporize. So those things are discussed in detail in geography, but at least when we are talking about the earth spin, it is spinning and its revolution, we must consider what will happen if spinning stops and if the revolution stops. That is for GK. These questions are mostly asked in National Defense Academy examination. In the next video, we will be doing some numericals based on the variation of G due to altitude, height, latitude, shape of the earth, and rotation of the earth about its axis. Thank you.